morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Vorhies, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. So I'd like to start off our event today by thanking IBM Analytics for sponsoring today's event. IBM Analytics is an integral supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Alteryx, Anodot, Statistica, Tableau, Teradata, and Crowdflower, to name just a few. Now, past webinars are available on demand at datasciencecentral.com, and if you haven't had an opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of interest to our data science community. Today's webinar is entitled The DNA of a Data Science Rockstar. And before we begin, I'd like to briefly review the format of today's webinar. Today's event will be an hour long. We have two panelists that I'll introduce in just a minute. There'll be 10 or 15 minutes of Q&A following the presentation, and this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation, because we'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. I'm very pleased to introduce today's speakers, Carlo Appugliese and Greg Filla of IBM Analytics. Carlo is a big data evangelist for IBM with expertise in open source, Apache Spark, and Hadoop. Carlo's a technologist with a track record of leveraging emerging technologies to help drive business innovation. He's held previous positions as a computer programmer, manager of application development, and director of innovation, with a good balance of understanding between technology, software development, architecture, business, organizational culture, and people. Now, Greg is an offering manager for data science experience in the IBM Analytics group, where he works to support online community and promote evangelism. He also works as a data scientist for the product, where he develops R scripts, Jupyter notebooks, and interactive dashboards that leverage data science experience to solve business and academic problems. So Carlo, Greg, thanks for being with us today. We're looking forward to your presentation. Now, data scientists are tasked with transforming their organizations with data. Yet many are struggling to realize their true rock star potential, and the organizations are missing out on what these rock stars could do with the right environment. So in today's Data Science Central webinar, we'll learn what skills, tools, and behaviors are emerging as the DNA of the rock star data scientist. We'll explore best practices for big data analytics through open source technologies like Apache Spark, R, RStudio, Python, and Jupyter. Techniques including machine learning and behaviors around collaboration, sharing, and learning. So Carlo, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Hey, thanks, Bill, and thank you everyone for attending. I'm looking forward to spending the next hour with you guys and talking about the DNA of a rockstar data scientist. So first I'd like to start with is we want to start with a quick poll, and let me make sure here. And for the poll, what I'd like to do is, let's see what is the top analytic job at your organization. So really quick, if you could just select whether it's a Chief Data Officer, a VP of Data Science or Analytics, Director of Data Science or Analytics, Manager, the Data Scientist, or Business Analyst. This really is a top job, the top analytic job within your company. When we have these big audiences, we definitely like to learn a little bit and poll and get some responses. So it looks like we have, wow, quite a balance. The data scientist comes in pretty strong here, and the analyst, but it seems pretty even across the board. Most companies have adopted some level of data science and analytics. However, there is all levels of commitment based on your company's data maturity and business model. So there's no right or wrong answer. Seems like the managers are a little weak is the only downside. But For a data scientist to reach rockstar status, it starts with your company being all in data and analytics. Let's talk a little bit about the landscape data scientists face today and why companies should be all in. So today we live in the digital age, and the digital age is changing how we live, play, learn, and work. An example, my kids play this game all the time, Pokemon Go. Millions of people are playing this alternate reality game, and this phone, this device, this computer is collecting hours of behavioral data. What do we do with that data? How do we exploit that data? We share and communicate all day long on our smartphones. For example, Facebook today is the world's largest content provider, yet they don't really create any content. It's all created by the user, by these digital devices. And shopping, we just had the busiest Black Friday shopping this past weekend. And I think this is the first year, but 10 million more people shopped online this past weekend than they did in stores. So imagine that, the busiest shopping time in the world, and online shopping surpassed traditional brick and mortar stores where everybody goes out and shopping. I guess it's true that nobody wants to face the crowds. This trend is likely going to continue, and major retailers are fighting to transform their business and keep their customers. Most people don't want to face these crowds, and that's the reason they want to stay home. They don't even want to get dressed. They just want to shop. And that's why these digital systems of engagement are really transforming industries. All of this digital innovation is happening with data like inventory, web clicks, geospatial health, and so much more. This is the landscape data scientists today have to deal with, and it's not an easy one to deal with. Digital businesses are disrupting every industry and profession. A Harvard Business Review found 72% of businesses are vulnerable to disruption in just 3 years. If you don't see your industry being disrupted by the digital age and this transformation, you might not be looking hard enough. But for example, banking seems like where all the money's stored is a safe industry, but a technology called blockchain, which is a distributed ledger behind the invention, Bitcoin, might be the future of banking. Who knows? Digital systems are transforming industries everywhere. 90% of business executives today see the need to transform, and yet 14% believe they have not been able to act on the data quick enough. If data is driving the digital age and you can't quickly act on your data, you'll be left behind. I spend a lot of time with clients helping them shift to a data-driven organization. This is critical, and the data scientists, particularly the rockstar data scientists, is critical for this transformation. Making the shift to a data-driven organization is difficult. Based on this Harvard review that I was quoted before, 84% of companies say that their data is fragmented and it gets in the way. And 80% of the companies say collaborating on common data is a big problem. 9 in 10 people require faster data and analytics to compete. This makes the data scientist role difficult to navigate. The data scientist is an essential part of faster data and analytics. And to reach rockstar status, you have to be able to navigate this landscape. And we will talk a little bit more about how to do that and some of the tools and what to do. The rockstar needs to work with all data, be able to collaborate with all data professionals in order to really be effective and be pervasive throughout your organization. So how do organizations engage faster data access and analytics? So every company is a little different, just like we started, where you saw that every organization has a different level of commitment for their top analytical job. So what we typically talk to clients about this data maturity model. As you can see first on the left, it starts with operational efficiency. Every organization focuses on operations and how to leverage technology to lower costs of systems that run their business. This has a lower value. Next is modernizing BI and data warehousing. This includes data warehouse modernization, incorporation of other data sources like semi-structured, reporting, analysts, and dashboards, and integration and governance. A lot of companies are dealing with this right now. And again, it's still a lower set of value. You really start to get value in the next phase of data democratization, self-service analytics, with the expanded data sources for open data, weather data, personal data sets, and predictive and advanced analytics, prescriptive and real-time analytics. This is where you start to introduce the data science methodology, the data scientist. And because of this environment we're in the digital age, big data is a critical element of this. And then in the last portion, the end of the phase is where you get the true value, where value skyrockets to the next phase of data monetization. New business models, initiatives are characterized as new web and mobile applications, new sources of data in motion like Internet of Things, sensor data, real-time predictive business models. This is kind of where the end goal is for many of these digital transformations that are happening. To drive up value of your investment and monetize data with analytics, we have to embrace big data and the data scientists, particularly the rockstar data scientists, to make this data scientist role pervasive throughout your organization, your systems, your applications, and your day-to-day processes. The Harvard Business Review recently called the data scientist the sexiest job of the 21st century. It's not just sexy. For millions of managers who need to solve business problems, get answers, implement new digital systems, transform their organizations, it's indispensable. It's not just managers, though. It's also chief data scientists, VPs, and directors. Talk a little bit more about the data scientist tooling and role. I'm going to hand this over to my partner on the webinar, Greg.
Yeah, thanks, Carlo. Thanks. Okay, so yeah, my name is Greg, and I'm going to start today talking about the skills of a rockstar data scientist. But before I get into that, I want to start with another poll question here. And so this question is, what skills do you think make a rockstar data scientist? So we have three options here for an answer. So do you think that it's more statistician than coder, that they're more of a coder than statistician, or that they're more of a business expert than a technician? So I'll give you a little bit of time to answer this for what makes a true rockstar data scientist. Okay. So a little bit surprised. So yeah, so what we see is, looks like the majority say that it's about more business expert than technician, which is definitely true. I'm surprised that coder didn't come up more, as we definitely have seen that the rise of coding skills has definitely become an important role for data scientists, and statistician definitely is an essential key component as well. Okay, so it's great feedback to see. All right, so now let's talk about what is a data scientist, just to clear this up if anyone isn't clear on what that is. So looking at this slide and the Venn diagram we have here, we have statistician, programmer, and business expert. And in the center of this is what a rockstar data scientist is. So they need to have coding skills, statistics skills, and also be an expert in the business. I've definitely seen other Venn diagrams like this that try and break down skills of a data scientist, and it's not limited to just 3 things, but it's actually broken down into 10 different skill sets. And it's definitely valid because a data scientist has to help out in so many different areas. But usually the skills roll up into these 3 main categories. So an interesting thing just to note from this is that the poll that everyone just took, and saying what's most important, that really varies based on the type of work or industry that a data scientist is working in, as well as the type of data they're working with. So for example, if you're a data scientist working with huge data sets, you really need to be a skilled programmer in order to really leverage the data that you're working with. Whereas maybe if you're working with smaller data sets, having that really advanced statistical knowledge can be more helpful for you. So just going into each of these categories a little bit more in depth and what kind of skills you're looking for specifically for each of these. If we start talking about statistical skills, so a data scientist definitely needs basic, statistical expertise and things like, doing descriptive statistics to understand their data, looking at things like hypothesis testing, understanding p-values, doing basic things like regression is definitely a must. That's actually, I just saw a survey from Katie Nuggets that regression is the most popular algorithm that's used. And so even though it's kind of basic, it comes up a lot. So having those core statistical skills are definitely important. Also, there's a need for understanding for multivariate analytical techniques, so this gets into more advanced statistics that are required. And then you're also looking at having just core skills like understanding linear algebra techniques, multivariable calculus, because these things are the foundations that a lot of data science is built on. So if you don't understand that, then you'll be kind of a shaky foundation, and you won't necessarily understand what the work that you're doing and the models that you're building as a data scientist. And finally, just an advanced skill that might come into play for data scientists is being able to actually derive and write out, whether it's in pseudocode or actual code, machine learning algorithms. So being able to do that can take a business from being, pretty highly performant to actually being exceptional by being able to re-implement an algorithm and tweak it to make it customized for their specific use case. Next, taking a look at programming skills. So programming skills, as what we've seen, has become a staple over the years. So this may not have been the case 10 years ago or so. But what we've seen is programming or coding has replaced a lot of GUI-driven data mining tools. So those are still around and they're still useful. But to supplement those tools and what they can do, coding is definitely a very valid skill to have. So looking at coding and open source technology, this has really opened a lot of new possibilities for data science. So if you're looking at new algorithms that have come up, so research papers are coming out all the time with new algorithms or techniques for problems, and if you're locked into some kind of proprietary software or something, then you may not have access to those new algorithms. So when we're looking at the skills for programming that a data scientist should have, definitely scripting, being able to clean data and create predictive models with code is necessary. Using languages like Python, R, and Scala, those are really popular data science languages these days. And then also, if you're looking at things like SQL to pull data with queries from databases, that's definitely crucial. And then data pipelines, this can all be done with code today. So this goes from everything from data ingestion to cleaning, model building, et cetera. All of this can be done with code. And then when you're looking at big data in Apache Spark, there are some GUIs that can let you access these tools, that kind of technologies work with big data. But when you want to get in and optimize things, you need to be able to code. And so finally, looking at business expertise. So it's interesting to see that this was the #1 response for the poll that we just took. And definitely having a deep knowledge of the domain is a requirement for a data scientist. What I've seen is that a lot of businesses, when they're hiring for these other skills like statistics and programming, it can be hard to find that complete package that is also an expert in the business who's hiring the data scientist. So a lot of businesses can try and teach the business skills, or have the data scientists collaborate with other people on the team to get a better understanding of the business and the domain. So these are, business skills. They can definitely be picked up on the job if necessary. But a true rock star data scientist is when you have high statistical knowledge, coding abilities, and business expertise. So now that we have an understanding of what a data scientist is, let's jump into what some individual skills or behaviors are that a data scientist will show. So first, a data scientist needs to be a team player. So looking at this slide, we have 4 personas that are typical of data teams across most organizations. So obviously we know the data scientist. The next important role is the business analyst. So business analysts work closely with data scientists and the other personas on this slide. And they are usually, the business expert or domain expert. So this is like I mentioned where, if you hire a data scientist and they don't have the business expertise, they should be working closely, on the team with business analysts to get a better understanding of the business. Business analysts use tools like SQL to pull data. They're doing things like exploring data with some basic statistics, such as correlations and things like that, to find relationships across the variables. And they're also exploring data with things like data visualizations. They could be using tools such as Tableau, Excel, maybe Watson Analytics. And then once they've created these visualizations, they're also another crucial task for them is to communicate the results. So this could be with the data scientists showing the insights that they found, or this could be with management and explaining, the problems that they're finding and what data is showing them. So next, let's talk about data engineers. And so kind of with all these personas as well, before I get into data engineers, there can be, definitely a combination of these skills can be found in one person. So definitely if you're at a smaller organization, you could be looking at this slide saying that you're doing all this stuff. So you could say, I'm doing data science, I'm building apps, I'm doing data engineering. And so this is definitely going to vary based on your enterprise. And so if you're at a small company, this may be just one or two people that make up all these different personas or responsibilities. And if you're at a larger organization, this could be something where maybe you have a team of data scientists, a team of data engineers, et cetera. And so it'll kind of vary. But for now, we're just going in depth on what each of these roles, really the skills that are required for each one. So looking back at data engineers, they're responsible for bringing data to the end user. So they need to make sure that the right people are getting access to the right data. And this definitely becomes a really critical role when you're looking at companies that have sensitive data. So whether it's healthcare data or other things like that, where the role's critical for business reasons, obviously, but then also for legal reasons. Data engineers can be the ones that are keeping everyone out of trouble. And this comes in when you start looking at data governance and restricting access to who's getting data. That can be a really important aspect. Data engineers help with data ingestion, getting data out of whether if it's stored in a data lake or database, and getting it to data scientists or business analysts that need to work with it. Okay, and so now the app developer is the person that works with these other, in the sense of a data team. They'll be working with these folks and building out or deploying models inside applications. So a data scientist also needs to be a collaborator. So looking at this slide, this is a typical workflow or life cycle of a data science problem. So I'm sure most of you are familiar with this, but if we go around this cycle here, it starts off with some understanding the problem and domain understanding. From there, you're moving on to ingesting data. And as you can see, the inner circle of this cycle matches up with the personas that I just mentioned on the previous slide. So you can see that starts off where a business analyst may have the business understanding and works with a data scientist, and they start working with a data engineer to bring in the data. And then from there, it goes to exploring, understanding the data. Then it moves on to transforming, where you're doing some data cleaning, data munging. And then it comes to time to evaluate. So this is where the data scientist is really going to take over, do some deeper analytics, and they will build a model at this point. And then from there, it'll, between the data scientist and the business analyst, they'll be collaborating and will, communicate the results. And then finally, at the end of the process, the application developer is involved, where they'll deliver and deploy a model. So, this looks nice and simple and, on the slide, but definitely when you're actually working through these problems in a real-world situation, each of these steps are going to be iterative. So you're going to be going back and forth between these steps. And the guideline in the center, just showing you who's involved, that shows you how much collaboration is key when you're looking at data science projects. And so, just in the first two stages, you have nearly everyone involved. So if a data scientist isn't able to collaborate across the team, then you're going to get held up at stages of this process, and it could definitely, slow down everything. So next, the next skill that we want to talk about here is that a data scientist needs to be a coder. So I mentioned a little bit about why coding is important on the previous slides, but I just want to point out a little bit more in detail why we see coding as being so important for data scientists. So definitely, flexibility when you're looking at why coding is needed. So languages, unlike some proprietary software, languages are always being enhanced. So you're not tied to some proprietary algorithm, like I mentioned. If there's a new machine learning library that came out, you're able to use that, and you can use the latest technology, the latest algorithms that are available for your projects. So it's definitely, that flexibility is very helpful. Looking at scalability, so with code, you can scale your workflow from being on a single machine to a cluster of machines. And so this is, later on we're going to be talking more about Apache Spark and big data and why that's important for data scientists. But using code is the best way to actually be able to scale up your data processing. Once again, if you're locked into, some tools that are focused on, on-prem on one machine, that's going to restrict you in the amount of data that you can work with. Next, the choice of tools. So data scientists usually have their favorite tools they like to work with. So for me, I like to work in Jupyter Notebooks, which is a development environment where you can code and have Markdown and have all your output in one place, so it's nice for reproducible research. I also like to work in RStudio, which is the main IDE for people that use R. And the choice of tools also it applies to the third-party libraries that you can access when you're coding. And there's many libraries out there that can help with data preparation, model building, and even creating interactive data visualizations. And finally, so community is also a key aspect of why coding is important. So open source communities are very active and full of contributors. There's always people to help. If you have a question, a technical question on something, you can reach out to the community and get some help. So that's another reason why it's really important. So I've definitely found that coding with data science has been tremendously helpful and lets you go beyond the skills that for what you would typically have if you're locked into a single tool. Okay, so next, a data scientist is also an innovative researcher. So what I mean by this is that a true rockstar data scientist is never, they never stop learning and researching. So the skills that I mentioned before, where I'm talking about, statistics and coding and even, business expertise, everything is built on practice and learning and constantly reading and finding out new resources and materials. The field of data science is new, it's exciting. There's tons of applications that are being spread across all industries and business functions. So to stay on top of that, to be a true rock star, you need to always be learning and researching. So you need to find a good way to be able to stay on the latest trends and techniques. So an example of this, so why innovation is so important is if you look at something like deep learning. So deep learning first came about in the 1960s. And really what this is, it's a name for when you have a neural network that has many hidden layers. And even though it was first discovered in the 1960s, it really took off in the early 2000s, when we started having better hardware to process these neural networks with GPUs to help reduce the computation time. And so since experts were doing research on this, on deep learning, and they started solving really, really challenging problems with it, now if you look, there's tons of frameworks and open source projects that are available in the community that have spread this. So staying up on the latest research will definitely help you stay on top of things such as deep learning, which is now everywhere in data science. And if you weren't aware of that, then you'd fall behind. Okay. So this is an example use case of a data science problem, and I kind of talked through this on the previous slide where we were going through the life cycle. But basically here, just a quick overview on the slide. You can see that from each of the personas that I mentioned, when you're working with a problem, each of the steps where you're moving along from discovering a problem with your data, and then working with a data scientist and data engineer to dig deeper in the problem. Everything's iterative and it requires collaboration. So you need to be able to do both those things to have a successful data science team. So moving on from here, I want to jump into another poll question for everyone. So we've talked about the skills that are required to make a true rockstar data scientist. And I've kind of covered some coding and why it's important, but I just want to get everyone's opinion on what language do you think a rockstar data scientist uses? So we have Python, R, Scala, SAS, or SPSS. So I'll give everyone a couple seconds to fill that in. Okay, wow. Exactly tied between Python and R. Scala is very low. SAS, definitely we've seen when you're looking at, definitely large or older institutions like the government, for example, you see a lot of usage of SAS. SPSS is very low on this poll, but it's really interesting that Python and R are tied here because that actually leads perfectly into the next slide that I have where we're looking at the trends of these over time. So I guess everyone's an informed audience here. And so looking at Python and R, so that's the green and the yellow lines, you can see that basically since 2013, they've been on nearly exponential growth. And then this is Google Trends, so this is the search terms for those two keywords. And you can see that the other terms that we had on the poll are kind of lower in comparison. So, this is search terms, but if you look at other indicators, so like job postings or questions on Stack Overflow, you'll see similar trends like this chart. So definitely Python and R have become tremendously popular over recent years for data science. And so now I just want to go a little bit in depth on these to talk about, how each of these fit together, and then also just mention Spark and how that plays a role as well. So looking at R, so if you're not familiar with R, it was originally created for statisticians, and some people still consider it that it's a domain-specific language for statistics. If you've worked with R recently, though, you'll know that that's really not the case. So the thing that has made R so popular in the past few years is really the community, and primarily in the community, what they have is CRAN, which is a repository of R packages available. And so these R packages offer things like I mentioned before, things that focus on data preparation, data visualization, et cetera. And these packages that are contributed by the community, they add so much value and so much, they really extend the R language. And so an example of this is Shiny, which I have the logo here. And that's a package that was created by RStudio. And what this does is it allows R programmers, basically data scientists, to become web application developers. So this is, just one way that the functionality of R has been extended through the community and through packages. Next, taking a look at Spark. So Spark is the main data science big data platform that people are using today. And the main reason for this is that it has bindings for different languages. So that includes Java, Scala, Python, and R. So if you're using any of those languages, you can easily move to Spark and start processing giant data sets. And Carlo will be talking in a minute more about Spark and how it's used today. And the last language on the slide I just want to cover is Python. So Python is pretty ubiquitous across all kinds of applications, so not just data science, but lots of other things as well. An example of a specific data science library that a lot of people use is scikit-learn. And so this is a library specifically built for machine learning. A lot of people think of Python as like a Swiss Army knife because it can really do everything, and that's why a lot of projects work in data science. They use Python because you can do your data preparation and modeling and then also use it to do other things that you'll need for an application. So that's a look at the technologies, and so now I want to hand it back to Carlo, and he's going to tell you more about Spark and big data and why it's important for data science. Carlo?
Thanks, Greg. Thank you. It was great polls. I love the results, and I love your comment about being an informed audience. It's good. But so here, let's talk a little bit about big data and the market evolution. So when you think of big data, you think of Hadoop. But it just recently and only hit top line within the open source development community, Apache Software Foundation. Apache Spark has hit the scene in 2014 and has quickly surpassed Hadoop with interest. As you can see here, it's skyrocketed. And part of the reason I'll go into in a little bit, but that when you have this kind of interest, you have a lot of innovation. And as a matter of fact, Spark is basically now the hottest open source project of all time when it comes to contributions within the open source community. Apache.org is a nonprofit that manages all of these community-driven software projects, and there's about 250. And IBM was a founding member back in 1999. But these community-driven software have thousands and thousands of people that are developing against it, and that's where you see these open source projects. And like I said, Apache Spark is hugely popular. So why is Apache Spark so popular? Well, first, it performs. When you compare it to Hadoop and MapReduce, it is 20 to 100 times faster than MapReduce. There's a reduction in the I/O, disk I/O, because of its in-memory architecture. But it's not just the in-memory usage that makes it faster. It also has a better compute engine, which allows it to perform even when you're making trips back to disk. Because of its what we call the lazy evaluation, and it has a DAG, which is a directed acyclical graph, which manages the lineage of transformation. Not want to get too deep in that, but it also is much more productive for people to use because of its unified API for a variety of analytics, It supports multiple common programming languages like Python, Scala, R, and it also has a procedural and the concise language, which makes it lot less lines of code. I've seen people take MapReduce jobs of like a couple thousand lines of code and reduce it down to 100 or 50 lines of code, and it's quite remarkable how much more efficient it is. Spark also has a very large community and is growing. And the other thing that's really nice about Spark is that it leverages some of your existing investments. And we'll go into a little more detail on that in the next slide. Let's see here. So let's get a deeper look into what is in Apache Spark. So first, you start with Spark is an open source in-memory application framework for distributed data processing and iterative analysis on a large data volumes. Apache Spark has a diverse set of analytic APIs. Now, the one thing to keep in mind when you compare this to Hadoop, Hadoop has to have, if you want to run SQL, you need Hive project. So it's a collection of a bunch of projects. Apache Spark happens to have a set of APIs that does a variety of analytics all within the same project, which makes it more efficient and actually a lot less problems with trying to deal with these multiple open source projects working well together. Some of the APIs you have Spark SQL for running SQL, Spark Streaming, you have machine learning, and machine learning here is the key to the Rockstar Data Scientist. So not only do you have to be a collaborator and some of the other things that Greg talked about, you also have to be a coder. And when you're coding with big data, your key is going to be around incorporating machine learning within your data assets. And then graph is something also you should keep involved in graph analysis is actually taken off and is quite interesting. All these APIs sit on a set of a core computation engine. This compute engine is the heart of the application. There's one thing to remember about Spark is Spark is not a data store. It's a computation engine. And so one thing to remember about this is the reason you use Spark and Hadoop is its distributed nature. So the more nodes that you add, the faster your analysis happens and the more data you can deal with. I mean, that's the true value. From a perspective of the computation engine, it sits on a variety of data sources. So you can access data within HDFS, and you can co-locate your processing, S3, object store. You can deal with documents on Mongo or Cassandra to relational data in your Oracle and DB2. This gives the data scientist the environment to pull these variety of data sources together in an analytic cluster and do their computation. So it's quite powerful, and Apache Spark can pull data into your cluster, transform, iterate, compute, and train models. To do a quick recap here of the DNA of a Rockstar Data Scientist, I wanted to really talk just to kind of capture it all together so we understand. But one, your data scientist needs to be a natural collaborator. The Rockstar Data Scientist the data scientist role is relatively new. To gain value, a data scientist must be part of the team and not just working on a science project or in a silo. So it's important that they're a collaborator. Two, we feel that the hands-on coder is also important, and that's because of this growing community-driven software. To embrace this, it's all very much part of coding, and they need to be able to do things on their own. So being a coder is going to give them that capability to do stuff on their own. They need to access data and have the ability to code new analysis and solutions from scratch, and that's the key with being a coder. Next, third, they need to be an innovative and researcher. This needs to be somebody that goes out and does research, that reads blogs, that shares some of their methodology, some of their findings and their techniques, and also to introduce new ideas into the data team. The data scientists really need to be that innovator within your data science team, which is really that broader group that Greg talked about. And then fourth, proficient in community-driven technologies. This is where we take the open source technology. It's important for these data scientists to really start to embrace those. I'm not saying that there's a lot of other very efficient data scientists on different technologies, just we're seeing a huge trend in the innovation that's happening with these open technologies. That's why we've embraced it in quite a bit of our platforms. And also proficient with big data and machine learning is critical to the rockstar data scientist. I wanted to talk a little bit more about, when we talked about Spark and what it is, but maybe a little bit about what IBM's doing with Spark. So we're heavily invested in Apache Spark, and we're invested in 3 areas. One, we're contributing to the open source community. We created the Spark Technology Center about a year ago, and we are the #2 contributor in Apache Spark behind the creators and inventors of Spark Databricks, which we're partners with. We actually have more contributions in Apache Spark than the next 5 companies. So we're very, very invested in Spark. And the second pillar there is the reason is we not only are helping clients use Spark, but we are also infusing Spark in our portfolio. It's part of our platform. From Watson to our cognitive capabilities, we leverage Spark's computation and analytic engine under the scenes. And then third, we are fostering community. We are actually have Big Data University training classes. We do live hands-on labs and webinars and all kinds of things to help grow the community and build out the data scientist role. So we're very invested with Spark. We feel Spark is a big part of the data science community. So if you haven't started to learn about Spark, maybe read up on it. The next thing I want to talk about is I want to introduce what we have recently announced, I guess a couple weeks ago, is the introduction of our IBM Watson Data Platform. This is a platform that is very simple. The idea is simple: to create a working environment for all data professionals that provides everything needed to introduce new business models and analytics in their day-to-day work. So make data analytics and data science pervasive throughout. That means expanding. So it's really hard to get these rockstar data scientists. So when you have one, how do you expand it? You surround them with the other data professionals so that their work is then shared. Again, not siloed, not a data science project, but part of the team. The Watson Data Platform is built in layers. It has an integration experience for all data professionals. So each data professional has kind of this user experience that's geared towards their work and what they're due, but it's integrated. It's on top of a common process layer of data flows, models, machine learning, cognitive, and analytics. We've incorporated quite a bit of capabilities in there. Those experiences, I forgot that I'm going to go step back up. They have the tools that in data science, particularly for data scientists, they have all the tools that you would want. Things like R, Studio, Python, Jupyter notebooks, everything that you may want to use. And we're also including SPSS, some of those drag and drop GUI interfaces within that experience, pulling it all together. And underneath, it's sitting on top of that common processes. And on top of that, it has a common data platform, which allows all data professionals to really go shop for that data on a set of common, again, data platform with catalog and capabilities. So it's a very exciting platform. It's really unifying the team, and it's making analytics become more pervasive throughout. And instead of having to build a new model, train a model, find new insights, then create a project for the business analyst, the application developer, and the engineer to build the app, it becomes more pervasive and accessible for those other data professionals. That's the key. So imagine, let me see. Okay, so the next slide, I want to talk a little bit about data science experience. This is the experience that the data scientists would use. If we dig deeper into this, you'll see really what it is. It's an environment that allows you to learn, to create, and collaborate. So in learning, you can build in tutorials. There's built-in sharing and capabilities within the platform. You could also create. So you have all the open source technology and value adds that we talked about a minute ago, from Python, Jupyter, and R. You have these capabilities all in your platform on top of that common set of data assets. And then you have some of the value adds that we were creating, things of like drag and drop, pipeline creation, a catalog for your data, and some really cool value adds to make it more simple for you. And then the collaboration. This is where you can share. We have this concept of projects in data science experience, which is really cool, which allows you to take all your data professionals, assign them in there, assign the data assets, assign the analytics, which is your notebooks and different things, together into that project, and then, you know, train a model, and you can deploy it, and then developer. Imagine an environment where your developer just goes and accesses an endpoint versus having to recode the entire model that was trained in your big data environment so you can deploy it out in the field. So that's kind of the vision. Data Science Experience is IBM. The URL is datascience.ibm.com. It's free to use. You can start using it today. So I encourage everybody to try it out. It just went GA. Some of the core, I think I covered some of this, some of the core capabilities of our community, which is you have tutorials, data sets that are all incorporated into the platform. When you go out there and check it out, you'll really, you'll see a lot of stuff out there. You can just do plain searches for different things, for different algorithms. And then open source, you have all the open source tools that you may use to with tutorials, so you can teach yourself. And then all the value adds that I talked about, from shaping pipeline UI, Spark as a service, which you have a Spark cluster under the scenes doing your computations, and some of the other advanced things. So with that, I'm going to put it back to Bill for our Q&A phase of the webinar.
Well, Carlo, Greg, thanks so much for that excellent presentation. We'll get started with today's Q&A, and I want to thank the audience for their participation. We've had a lot of questions that have come in during this presentation, so we'll do our best to get through all of them in the time remaining. And during this Q&A, I'll leave up this screen with contact information for Carlo and Greg if you'd like to contact them following today's webinar. So let's get started. Let me divide these questions this way. There are a number of questions that have come in that relate to people who are looking to become data scientists or looking to improve their skills as data scientists. So let's start with a simple one. Where should I go if I'm new to data science, if I want to learn those skills?
Hey, Bill. Yeah, so this is Greg. So there's a ton of resources online for learning new data science skills, but just to kind of point back to what Carlo was just speaking about on data science experience. So we didn't show it today, but they have there's a ton of content available in data science experience, and so there's a lot of blogs, tutorials, and as well Jupyter notebooks that have been created by data scientists at IBM. So that's a great way to get started. You can learn from what experts are doing and get started that way, and that's more of a hands-on approach. Another service from IBM is called Big Data University, and that's a product that has courses available. So if you want to get more of an academic approach and learn a full technique in data science, Big Data University is definitely a really good place to start as well.
Terrific, thanks. Excellent answer. Now, throughout your presentation, you've emphasized the need for data scientists to be coders as well as data science statistical experts. Is coding a requirement even if you don't have big data?
That's a great question. Big data helps. So when we talk about big data, sometimes we also talk about machine learning. And with machine learning, to iterate through these models, even against small data, having the big data architecture allows you to get your answers quicker and to train your models faster. And Greg, maybe you add to this, but in my opinion, big data also works with little data. But to answer your specific question, Python and scikit-learn and some of these other coding kind of APIs and libraries all provide a lot of advanced analytic and data science capabilities that you kind of miss out on if you don't at least experiment some. And it's not like you have to be a very proficient coder. Just I would encourage everybody to maybe start to learn Python if you haven't yet. It's quite simple, and Greg, I'll let you add up on this since you're hands-on a lot more than me, but I am hands-on too. Do you have any thoughts on that, Greg?
Yeah, no, I definitely agree everything that you said. The only thing I just want to add is that one advantage. So if you're starting a project and you have small data sets that you're working with, and maybe it seems like I can just handle it in Excel, or some other tool like that. Once you start having your data sets grow, that's really when the coding pays off, and that's where, being able, so if you start with code at the beginning, then it's going to be much easier for you to scale up as your data grows. So that's the only thing I would add to your answer there.
Yeah, those are excellent comments. Thank you very much. Now, you spent a lot of time in your presentation emphasizing how important Spark is these days, and I certainly agree. But Hadoop went open source in 2007, so we've had almost a decade of folks working in Hadoop. You didn't mention Hadoop as a core skill for data science. Is it worthwhile falling back and picking up Hadoop skills in addition to Spark, or should we just move directly to Spark?
I'll jump in on this one. In my opinion, prior to coming to IBM as a director, I spent a lot of time implementing Hadoop, and I had a team of architects, data scientists, and I was also hands-on myself. It's a lot harder. Spark has made everything a lot easier, particularly for the data scientists. My opinion is just jump into Spark. Don't worry about Hadoop. I mean, understand the architecture, understand how it works, understand that some people use Spark with Hadoop together, but I would just jump into Spark, learn Spark, learn PySpark, where you coding with Python and Spark, learn how to create create data frames, work with data frames, run Spark SQL, do all those things. And I usually have a chart that I actually show. And to be honest, if you look at the job trends in the last year, for Spark skills, it's skyrocketed. So if you want to, I would recommend go right into Spark. Don't worry about Hadoop. Greg, I don't know what your thoughts are on that.
Yeah. Thanks, Carlo. Yeah, I agree. The thing if you're a data scientist or you're looking for a job, for example, or something, if you start off learning Spark, I mean, there's a ton to learn just focusing on Spark. And to reiterate Carlo's point, definitely understanding the Hadoop, HDFS and how that works, the architecture, that'll be important for you. But the value that you'll get from learning Spark will definitely outweigh what you would, for the same investment in Hadoop. So, as a data scientist, focus on Spark, machine learning that's available there, and you'll be able to do a lot of cool stuff.
I certainly agree. Spark is absolutely our current hot horse to ride. Now, one of the interesting things, Carlo and Greg, that you two have that a lot of us don't have is you get to meet with a lot of folks who work in data science all the time through your clients and your project work. So let me ask you, what percentage of the data scientists that you meet are actually rock stars? Who qualifies?
So I'll start with that. I tend to meet with a lot of rockstar data scientists, but we use that title in people have different aspects of the rockstar data scientist. So I don't want anyone to think that they're, if they don't have all these things, that they're not the rockstar. But the key here is we wanted to make sure we focus in on there's guys out there that have all the technical skills, but they don't speak up, they don't collaborate, they don't share. And if you don't do those things, you're not going to be a rock star. So it's really a combination of getting some of those technical skills enough to be part of that team, to collaborate, share, and speak up. And I think that's what makes those rock star data scientists. Within my old organization and within IBM, working with different clients, I always could tell the guys, they speak up. And then some of the other guys are super smart and they can do their job and do their work, but they tend to keep to themselves and they don't share and collaborate. So we find that collaboration and sharing is a critical element. And Greg, I don't know what your thoughts are. I want to make sure I don't overspeak for you as well.
Yeah, just the one thing I would add there is just like we mentioned a few times, that data science is or that title or that term is relatively new, and so there's still a ton of work that's being done in the field. And so the one thing just to focus on is that you may not be or you may not consider yourself a rockstar data scientist today, for example, but what we talked about with constantly learning and researching and staying on top of everything that's new, that's what's going to help you become a rockstar data scientist in the future. So if you have the mindset of a data scientist where you're looking to solve problems and you can kind of think outside the box and work well with data, then as long as you're staying on top of the latest trends and research, then you're going to be successful. So I'll just add that.
Those are great answers, and I absolutely personally agree that one of the wonderful things about this profession is how rapidly it changes and how much we have to keep learning constantly in order to, stay in front of what's going on. So let's switch gears a little bit, and let's talk about some of the questions that the audience has asked from a company perspective. And early on in your presentation, you showed a slide that showed a progression from descriptive analytics with business intelligence and data warehouse through self-service on to predictive analytics. And the audience wanted to know, in your experience, how long does it take a good-sized company to actually move through those various phases? What's a reasonable expectation if you were just starting out to move down that path?
Oh, great question. So when you look at that maturity model, I don't want people to think that you only have to go from one to the other. It is a maturity model, but we've seen, for example, startups actually jump right to new business model, new business imperatives. So there is really no set time frame, but I've seen companies take 2 years to do their data transformation, big organizations, but I've also seen companies take 6 months. So I don't see many companies that can do it within a month. I haven't seen anything that fast, but I've seen transformations happen in 6 months and up to 2 years. If it's taken longer than 2 years, then you might want to reevaluate it. Sometimes, so I feel like it should take a year.
Right, and
every company's different. Sorry, go ahead.
I thought a very important point that you made was that it doesn't have to be linear. For example, you could move from descriptive BI directly to predictive, and then maybe loop back and bring in a larger percentage of the people in the company using self-service even after the fact.
Yeah, and we have a thing we do with clients, and it's available. And I could help set anyone up that wants it. We call it our data first method, and we go through where you are as an organization within your data maturity, where you're trying to get to, and you could skip steps, and get right to that new business imperative. And it really comes down to nailing down what those use cases are, and then how to build your platform and your tool sets in a way that all your data professionals are proficient with data science methodologies and accessing their data, and then being deployed in your digital system. So we can help with some of that. If you want, reach out with some of the email contacts we have there, I can help set something up.
Well, I think you probably just answered the next question, but let me ask it. The question from the audience is, if we're just starting to hire a data scientist, what's the most important thing to hire for? Clearly what you just said was planning, but go ahead, take it from there.
Yeah, I would look for someone who that has community type software experience, open source software experience, somebody that's done Python models, that knows what big data is, and as well as, I always hire based on my I hired a lot of people, but I typically also hire based on personality, because I've hired some very talented folks who are very want to share and open. So I always go back to that collaboration sharing. But I would definitely look at some of the skill sets we listed back there. Python, R, and Spark or Hadoop, and they can learn. People can learn some of those skills. Greg, do you have anything you want to add to that though, or?
Yeah, I would just add just like a problem solver mindset. Just seeing a history that someone has. Even if they're relatively new to the area, if they have those technical skills and they have shown, in their experience that they've, been able to come into a new company or something and solve some problems working with data, I think that's a good indicator that they're going to be a successful data scientist.
Well, Carlo, Greg, thank you so much for those great answers to some great questions. And for those of you who asked questions today that weren't answered, we'll be sending all the unanswered questions to Carlo and Greg and the IBM Analytics team so they can follow up with you after today's webinar. I have just a few quick announcements. If you'd please mark your calendars for December 6th, that's our next DSC webinar, which is the Science of Color and Visual Design Principles. That'll be presented by Tableau. Also, remember, today's taping will be available for on-demand viewing later today, and you can find that on the home page of datasciencecentral.com in the Webinar tab that's located at the top of the page. Well, this brings today's webinar to a close, and I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Carlo Appugliese and Greg Filla and IBM Analytics for their sponsorship, and for our speakers for their insight into today's topic. So my name is Bill Vorhies. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on December 6th. Have a great day.